All right, in this video, we're going to continue talking about quadratic functions. And specifically, we're going to talk about the domain, range, extreme values, and axis of symmetry. Okay, so the domain first. So the domain of any quadratic function is negative infinity to positive infinity. That is all real numbers. Um, So that's pretty straightforward. There are no issues. Remember, the only two issues that we really talked about were the division by zero issue and the square root or even root issue with finding domains, and the quadratic has neither of those issues. So the domain is all real numbers. So that's pretty straightforward. The other issue is whether or not the range. That's going to depend on whether the graph opens up or down. So let's say that the graph opens up like this, and that vertex is HK. That means that if you go right over here to the y-axis, right, then the range will be everything from K right on up the y-axis here. So this will be the range. All real numbers greater than or equal to K, right? In interval notation, it would be written like this if the graph opens up. On the other hand, if the graph opens down, like so, okay, and the vertex is again HK. Then if we went straight over to the y-axis, right, that's where K would be on the y-axis. And then just kind of looking where the graph is located, it would be from K down. So that would be from minus infinity to K. That's if the parabola opens down. And again, another way to phrase that, as we mentioned in the previous video, is if the leading coefficient is negative. Okay, so that's the situation for the range. For extreme values of quadratic functions, a quadratic function either has a lowest value, right, a lowest point in the graph, or a highest point in the graph. And again, that depends on whether or not the graph opens up or down. Okay, if the graph opens up, in this case, right, where A is positive, the graph opens up like this. And so that means that that the lowest y value that you could have is K. So the graph would have an absolute minimum or minimum value of K and no maximum value. It's going to keep getting bigger and bigger. There is no highest point on the graph in this case. And then the other situation is if the graph opens down, which we know that the graph will open down if the leading coefficient is negative, right? That's the number with x squared in the general format. If it's negative, it'll open down. And that will mean that the vertex is the highest point on the graph. So the absolute maximum value will be K, right? That is the y value of the highest point on the graph. And there will be no minimum value in that case. Okay? So that's the situation with those. Okay, so let's take a look at these examples. Again, I have them worked out here in this slide. Okay, it says find the domain, range, and extreme values of the quadratic function. So again, we're going to use these same examples that we used in the previous videos, negative 1/2 x squared plus x plus 4. Okay, and the facts that we know about it is, number one, we know that A is negative, right? So this parabola opens down. And in the previous video, we found that the vertex was 1, 9/2. Okay. So these two pieces of information are going to be important, not really for the domain, right? Because the domain of every quadratic function is the same, all real numbers. but it is going to be important for figuring out the range, right? Here we know that this parabola opens down, right? And we know that on the y-axis, that highest point is at 9/2 on the y-axis, right? And so the range will be all real numbers less than, right, or equal to 9/2, like that. And the absolute maximum value is, oops, that should be -9/2 there. I have a little typo. Oh, sorry, that should be positive there. Sorry. See, did I have that on the previous slide? Let me double check. Yeah. So that should be a +9/2 there. Sorry about that. Okay. And the absolute maximum value, again, is going to be, in this case, maximum, right? Because the parabola opens down, is going to be +9/2 there as well. The absolute minimum value does not exist. Okay. All right. Next example, we had f of x equals x squared plus 1. And so, just analyzing the situation with it, a is 1, right? The number with x squared is 1, so the parabola opens up. A equals 1 is positive, so, the vertex we already found is 0, 1, right? In one of the previous videos. The domain, again, is the same for all quadratics. It's all real numbers, -infinity to infinity. The range in this case is going to be 1 to infinity, right? So from the y point of the vertex up, because the parabola opens up. And then because the parabola opens up, there is no absolute maximum value. The graph just keeps going up and up on the y-axis. And the absolute minimum value is, again, this is a typo here. Sorry for that again. Is 1 on this case, right? Not 0. All right, let's take a look at those two examples. Okay, so the first one was this one, right? There's the maximum value of 4.5. That's the y value of the highest point on the graph. And the lowest point in the graph, right, for this one was 1, so the minimum value is 1, right? That's the y value of the lowest point on the graph. Also, it doesn't, you can plug in any number into this, right, equation, or into this function. The lowest number that you will ever get out, right, is 1. All other numbers will be bigger than that. All right, next example is find the domain, range, and extreme values of the quadratic function minus x squared minus 2x. Okay, so again, going through, we see that a is -1, so the parabola opens down. And in the previous video on finding vertices, however you want to say it, we found that the vertex of this parabola was -1 to 1, or -1, 1. The domain of any quadratic function, so this one included, is -infinity to infinity, or all real numbers. The range, right, is from the y value down, right, because the parabola opens down. That would make the maximum value of this 1, right? And there is no minimum value, right, because it opens down. So, looks like this. It opens down on, if this is the y-axis, right, which this is not an accurate drawing because really it should be over here. We'll see an accurate drawing in a minute, right? But we know because this vertex over here has a y value of 1, right, and that's the highest point on here, that would be the absolute maximum value. And the range would be from 1, right, from -infinity to 1. There. All right, let's look at the graph of it on Desmos so we can see an accurate graph, right? It looks like that. And there you can see is the vertex of 1. The range, right, would be from negative infinity up to this 1 right here. Okay. The next topic in this video is the axis of symmetry. The axis of symmetry is a line that runs, the vertical line that runs through the vertex. Okay, and so if you know what the vertex is, then you know what the axis of symmetry is. And it's just x equals, and then whatever the x coordinate of the vertex is, and that's it. Okay, so for instance, on this first example, we have f of x equals minus 1/2 x squared plus x plus 4. In a oops, I'm going to switch over to this where I have all these worked out. In a previous video, right, we found that the vertex of this quadratic function was 1 9/2, or the parabola, however you want to say it. And so x equals 1 is the axis of symmetry. And that's it. Let's take a look at the axis of symmetry on Desmos. So there is the parabola in question. And then if I graph x equals 1, and usually I draw these kind of as a dashed line to indicate that, you know, that's not really on the graph of the function itself. Okay, and you can see the axis of symmetry just kind of basically cuts this parabola right in half. It goes right through the vertex. And if you, say, printed this out on a piece of paper, and then folded that paper exactly along the axis of symmetry, right, what you would see is that every point on this side of the parabola would exactly line up with exactly 1 point over here on the other side of the parabola. In other words, it's kind of a mirror image from this side to the other side of the parabola. Okay, and so it's pretty straightforward. Once you find the vertex, it's pretty easy to find the axis of symmetry. If I have the second example, f of x equals x squared plus 1, then we found that the vertex was 0, 1. So the axis of symmetry for that one would be x equals 0. So, and x equals 0 would look like that. So there you can see that cuts right through the vertex. And the last example is this quadratic function, the opposite of x squared minus 2x, and we found that the vertex of that was negative 1, 1. So that makes the axis of symmetry x equals minus 1. And so going here, and changing that line. All right, so there we can see that the line x equals minus 1, which is the vertical line that goes through minus 1, goes right through the vertex, and that again cuts the parabola in half. Okay, so that's it for this video. In the next one, we'll be talking about the standard form of the quadratic.